All right. Test reminders. Remember, you are writing 2 tests. 1, open book and graphic calculator allowed. But is it needed? No. You may use it. And then you're going to write a second one that is normal. Why? Because I want you to show me that you can do stuff without the stress of having to remember. Because in the real world, if you are tasked with a problem, you have research available to you. All right. I'm going to do this in a slightly weird order. Okay? I'm going to do this in I'm going to start with the quadratic formula because it is the most versatile thing you have learned this unit because it'll do a whole bunch of stuff for you, right? The quadratic formula finds you the roots, it gives you a discriminant, and it's the reason you're able to use negative b over 2a. So I'll start with that because you can almost always use the quadratic formula with every question. That will find you the roots. There will always be one of 3 options. 2, 1. Is it really 1? No, but it appears as 1. Or 0. That is all from the b squared minus 4ac. If that is less than 0, I want to put it in the right order. If it's 2, it's greater than 0. If it's 1, it equals 0. If it's none, it's less than 0. So it's real easy to check if you're doing a question. Everybody should be comfortable with that. Remember, all you do to solve this is sub in that. And then you use your old-timey calculator to get a decimal answer. All right? Remember, these roots are either some number. What's the letter we never use? What's the letter we never use? Z looks like a 2. J. J plus or minus K root JK, I don't want to use L. I'll use L. It's either that, which is an exact answer, or I run that through my calculator to get decimals. When do I want a decimal answer? When would I want you to run that through your calculator? Other way around. This is the exact answer. But does this help me? How fast was he going? 3 plus the cube root, or 3 plus 7 root 4, or 7 root 5. That's how fast he was going. So I'm going to jump in the car, step on the gas until my speedometer reads 7 plus 3 root 5. Does any speedometer show that? No. So when do we need decimals, McKenna? When I need a real life answer that I can actually report to somebody. Everybody cool? Next thing. The 3 forms. All 3 forms give you different things. Vertex form. Not A, idiot. Y equals AX minus. Do you want P and Q or H and K, or do you care? P and Q, even though it's the same the way I wrote it with the factored one? That's not going to confuse you because P and Q in factors isn't the vertex. But P and Q in vertex form is the vertex. Okay. Yeah? Yeah. What do we know from there? The vertex equals opposite P value and regular Q value. Yeah? And A, I'm going to do A at the end because A applies to all three of them, right? Opposite P value, regular Q value. Yeah? There are three ways to get here. 1, complete the square. Complete square on ax squared plus bx plus c. Remember, to complete the square, ax squared plus bx plus c equals y. Move the c. Ax squared plus bx equals y minus c. Then factor out the a x squared plus bx equals y minus c. Then complete the square there. And remember to add new value to both sides. So that's number 1. You can complete the square. What's the second way I can get the vertex form? That's number 1. Number 2, negative b over 2a equals vertex x. And what do I do with vertex x? Sub back into ax squared plus bx plus c equals y to get vertex y. What's the third way I can get it? Find the roots, and root 1 plus root 2 divided by 2 equals vertex x. And then I can go back to there. Is everybody good? Yeah? Okay. Second form that we dealt with is standard. Ax squared plus bx plus c equals y. What do we know about standard? C equals y-intercept, which means that value on the graph is 0, c. That is an x, that is a y for subbing purposes. For subbing purposes. Right? Yeah? And remember, A is still there, but I'm going to deal with A at the very end. And lastly, our third form was factored form. Oops. Y equals A, x minus P, x minus Q. Now, please notice I've put the y on both sides as I've been coming down this line. Why? Why have I had the y on the right sometimes and I've had the y on the left sometimes? Because it doesn't matter. You can move this stuff around any way you see fit. All right? If you like working with positive x's better, and your positive x is on the right, then move the y to the left. If your x is negative and you don't like it there, move it so it works. All right? And in this one, our roots are opposite p-value and q-value. Q-value. Right? And once we have those roots, r1 plus r2 divided by 2 equals vx. Is everybody good? Yeah? Now, you should have another blank page, do you? Yes. Excellent. Turn that page over, and let us now deal with A. We remember, A is the stretch value. It affects the range values. Range values are which letter? Y values. Remember, every parabola moves from the vertex. I'm going to put a big dot for vertex. They move right and left on the x-axis. They then move up or down. If it's down, it was negative A. If it's up, it was A. A, negative A. It moves up A times x squared, or negative A times x squared. Remember, if there's no number there, what's the number there? 1. So this has an A. Sometimes A is 1. Okay? Remember, whole number coefficients, whole A values make this kind of graph. It stretches it this way. Fraction, and of course decimals, fraction A values stretch it this way. Any other questions about A? About what it does? Okay, how do we find it? We almost always, and I forgot to write almost, I just wrote always. So we always, almost, shut up. It's hard to do this. We always almost find A last. Get your form, whatever it is, and sub in a point to isolate for A. Unless, of course, you can count it, right? Like if you can see on the graph you've gone over 3 and up 27, then what do you know about A? Pardon? Yeah, it's positive 3. If you went over 4 and down 64, what is your A? Negative 4. If you went over 2 and up 1, what is your A? No, over 2 and up 1. 1/4. Because you should have gone over 2 and up 4. Right? Everybody's cool with A? What else do we have to remember about A? We just talked about it, I forgot. A is that Negative A is that. A is a tongue, or A is a uvula, negative A is a tongue, according to my grade 10s. I don't know what their fascination with the word uvula is, but I mean, it is kind of a fun word to say, really. Now, all that is everything you need to know, yes? X and Y, you need to remember from grade 10, are only definitions of the axes. If I am graphing height of a ball against time, one of those is X, one of those is Y. If I am graphing your height against your age, one is X, one is Y. Right? You got to know that. That's dependent, independent variable. You brought that from grade 10, or at least you're supposed to have. That is all the skills you need, except a very quick reminder of the graphing calculator. We remember, we hit the Y equals button, and we enter our equation, except our equation must, enter our equation, it must equal 0. So let me give you an example. Let's say you get in the question, it talks about the height of the ball, or a ball is dropped from 200 meters. Everybody cool? So I'm not going to write it down. I'm just going to say it out loud. A ball is dropped for 200 meters, and it is modeled by this. That's the speed the ball travels when you drop it from 200 meters. So what is h here right now? Right, but I just told you that I'm dropping it from 200 meters. So I'd have to put 200 here, yes? This cannot go into my graphing calculator. Because this y, the button says y equals, and right now this says 200 equals, doesn't it? So what do I have to do with that number? Move it over. So what actually goes into my calculator? I hit the y equals button, and it's negative 4.9t squared minus 25t minus 183. Does everybody understand that? That's how you use the calculator. Do you ever have to use your graphing calculator? No, we've proven that. We've done a ton of questions using regular old-fashioned calculators, yes? But once we have entered our equation, first thing we got to do after entering the equation is hit the graph button. Once we hit the graph button, we are fraught with possible problems, yes? The first problem, maybe there's no graph on the screen. It's just empty. What do we got to do? We got to either check zoom or change window size. Yeah? Once we get our graph working, we have to push second calc, which will then lead us to one of our options. Maybe we need the what? Roots, but your calculator doesn't call it a root. What does it call it? Nope. Zeros. Maybe we need the vertex, but it doesn't call it a vertex. What does it call it? Max or min. If it's a maximum we seek, then that means our A was negative. Is this negative? So it's a maximum. If it's a minimum we seek, our A was positive. The other thing we may be seeking are intersections. If we have two lines on the graph, right? And we find almost all of them the same way. A left boundary enter a right boundary, enter, and guess, enter. Now remember, there's one thing on the graphing calculator that I haven't reviewed here. That's that value button, right? That you can use. You can use value to enter an X value and get the corresponding Y value. Okay? Which, of course, is useful mostly for checking, right? Or you have a question like, how high is the balloon at 17 minutes? Well, once you've graphed it, you can push second calc value, x equals 17, because time would be on the x. And then you'll get the height right away. You don't have to trace along the parabola to find where x is 17. Everybody cool? That's everything I got. Your open book test that is coming up, you should be able to complete it simply by looking at pages 123 and 124 or whatever these are. Everybody cool? All right. I can't remember when class ends. 35, so we got 15 minutes. What is better for you? To try some, tell me, I'm going to say a few things, you tell me what you're comfortable with. Just a regular old quadratic equation. Are you comfortable with that? Inside, outside, upside down, backwards, underwater, in your sleep, written in Greek, written in Sanskrit, but spoken to me in Aramaic? Yes? Okay. Real life situations, using those? No. All right. Let's do a couple of real life situations then, using them. You don't need to write this down. I'm recording it, or you can find some space and write it down. Okay, I got one that I've had on other tests. And it is very applicable to now. Carbon levels in the air. Can be modeled by, what is that done? What the hell was that? Can be modeled by this equation. Excuse me. A, T. Carbon levels, which are A, are a function of time, yes? The longer we are pumping carbon into the air, the higher the levels of carbon will be. 0.3 T squared plus 0.1 T plus 4.2. Okay, that's the equation. So the types of questions I could ask with that are when will carbon hit level 8? Is that 8 a time or a level of carbon? So where does that 8 need to go? Does it need to go for T or does it need to go for AT? AT. So I would write 8 equals 0.3 T squared plus 0.1 T plus 4.2. Yes? And I want to know when this is the case, right? So I got to solve for T, yeah? Except what do I got to do with that 8? I got to move it over here. So now 0 equals 0.3 T squared plus 0.1 T minus 3.8, correct? And now I have an A, a B, and a C. So I could do what? Quadratic formula, or punch it into my graphing calculator and find the zeros. What's going to be weird when I find those zeros? One's probably going to be negative, one's going to be positive, yes? Does the negative one count? Why not? Can't go back in time. Everybody cool? Okay, let me give you another one. Let's try this one. Okay, it's wintertime, yes? It's becoming wintertime. Don't lawyer ball. It is, of course it's Christmas. Halloween's passed, so it's obviously Christmas. Okay. I own a surf shop. I sell wetsuits. Wetsuits at $275 each. No, that's actually pretty cheap for a good wetsuit. Everybody cool? All right. Summer is over. We are approaching winter. I have a bunch of wetsuits left. Everybody cool? All right. So wetsuits at $275 each. In the summer, I sold 90 of them. Everybody all right with that? Easy peasy. Makes sense, right? It's summertime. People are going to the water. Everything's good. Okay. Now it's fall. Nobody's going surfing. They're thinking about going skiing and snowboarding. So I got some wetsuits left over. I dropped the price, $15 price reduction. And I notice I sell a bunch more wetsuits, even though it's fall. A $15 price reduction equals 5 more wetsuits. So logically, what if I drop it by $30? I'll sell 10 more. What if I drop it by $45? I'll sell 15. When can I stop dropping the price? When I lose money, right? I don't want to hit zero. I don't want to pay you to take this wetsuit, yes? So I got to figure out a way where I can lower my price, but maximize my profit, yes? So if I'm trying to maximize my profit, I'm trying to look for an upper level, yeah? So would it be a happy or a sad parabola? Sad, right? Because there is no upper limit on a happy parabola. Okay, so let's talk about this. When I sold my wetsuits originally, I sold them at $275, yes? And $275 times 90 wetsuits, that equaled my money, right? Everyone agrees? All right. But if I docked $15, what happened to my 90? It became 90 plus 5, yes? Okay. Well, what logically then would happen if I dropped it by 15 twice? It would be 90 plus 5 twice, correct? What if I dropped it thrice? 90 plus 5, 3, yes? I am seeking the magic number that I can drop it and keep my money as high as possible. Do I know that magic number? So what do we give it? X. 275 minus 15x. 90 plus 5x equals money. Now, isn't that a quadratic formula or a quadratic equation? In what form? Factored, but it looks weird, yeah? So it'd be really hard to graph that. So what could you do? You could expand it, and then what would you have? You would have standard form, which would give you an ABC, yes? But the order would be weird, wouldn't it? Would some of you get fooled? Yeah, some of you would. 275 times 90 is some gigantic number. Who knows what it is? I can't do it in my head. Well, actually, I probably could. 300 times 90 is 27,000, but I'm losing 9. Fine. plus 275 times 5x minus 90 times 15x minus 75x squared. Collect those like terms, you got a standard form equation, you could work it out. Right? Once you have that standard form equation, you're seeking the maximum. What are you trying to find? The vertex. Vertex x, vertex y, or both? Depends on the question. What can I lower my price to? That would be the vertex x, yes? Right? That's the price reduction I could do. Yeah? So what if it was x equals 5? I find the vertex equals 5. How much does my wetsuit cost? 275 minus 15 times 5. So what would be the cost of the wetsuit? 200. Everybody understand? Because the x is the amount of times I drop the price. Everybody cool? That, ladies and gentlemen, is how, in case you care, businesses work. All of you have been to a concert, yes? Like a big concert in a big stadium, have you? Okay, some of you have. You've been to a hockey game. You've been to a movie. Excellent. When you go see a movie, are every seat filled? Often. Not usually. And you may think to yourself, well, it's $15 to see a movie now, or whatever it costs. Right? Why don't they drop the price to 10 and have this place full? They've done this math. They may drop the price to 10, have the place full, but not quite make enough money. They know what they can charge for a ticket and have their parabola hit as close to the max as possible because they're doing this type of math. This type of math, I know you don't believe me. This is Facebook, Google, Instagram. This is how they make money. They make guesses and they project based on data. Manipulating data like this is where the jobs are. Okay? Okay. It's 9:31. When did you say class ends? In 4 minutes? Great. I guess we're marking the review Tuesday. So now you got the rest of the 3-day weekend to not do it. What? The day of the test is Wednesday. That's what's written on the board. No, it's not written on the board. It'll be written on the board, but it's recorded for posterity. Hopefully there's sound. Yes, the recording levels are there.